Today we're going to be talking about writing our first program on the Pico. The assumption is that you have a Pico, that MicroPython is installed on it, and also that you have Thonny installed and have started to run that. All right, so first of all, let's talk about the specific circuit that we're going to actually create here. So the idea is that we're going to use this little Pico, and then this is actually the microcontroller right here, to control something outside of it. And a very typical way to get started is by, hey, let's turn on and off a little LED. Can you hand me that LED, please? Okay, thank you very much. All right, so whenever you create a circuit, I do recommend that you use a circuit diagram. So I'm going to get started and draw a circuit diagram for us here to guide us actually building it. So usually when you have an LED, you connect it to some form of a battery. Maybe there's a button in between and so on, but it gets its power, the current that goes through it comes from a battery. When you're using a Pico to control an LED, the voltage that you supply is actually coming from the Pico itself. And the way that the microcontroller actually communicates with the outside world is through any of these pins. So the idea is we're going to tell the Pico to set the voltage on one of its pins that's capable of doing this to a high value. And for the ground, we'll actually be using a ground that's provided on the Pico. Okay, so let's go ahead and create the circuit diagram for this. So when I refer to a pin, a lot of times the way that I diagram is I just draw a little circle, meaning a pin, and I am going to arbitrarily pick pin 9, and I'll show you where that is in a minute. After the pin, there is going to be a resistor. I'm going to use a 330 ohm resistor, and then there is the LED itself. Its circuit symbol looks like this, with two lines coming out. And then finally, to close the circuit and make it all work, it needs to go to a ground value. Okay, this is the circuit that we're going to be building in order for the Pico to control the LED. Now, the question is, how do we figure out where this pin 9 is? Now, this is a little bit confusing because you might be tempted to look at the numbering on the breadboard. But unfortunately, the numbering of these pins is not apparent from looking at the top. They're actually, the labels are on the bottom. So what I have done is I've created a handy little handout here. And when you are working with the Pico, I recommend that you have this at your fingertips at all times. So the idea behind this is, if your Pico has been placed into the breadboard exactly this way, so the USB cable is up here, the first pin is in the first slot, and so on, then we can use this mapping between the Pico pin numbers and the breadboard pin numbers. Now, for the purpose of this first program, you can ignore everything outside of these two strips. So let's say that we were looking at one of these GP pins, and GP stands for general purpose. We will be using a GP pin. As a matter of fact, we'll be using GP9. So if I wanted to know where GP9 was, I could actually just look at the corresponding number on this sheet, and that would tell us which pin on the, it would tell us which socket on the breadboard to use. Okay, so hopefully that is clear to you, but if not, let's actually just test your knowledge. So I wanted to use, I said GP9, or in Python, we just use 9. So where is GP9 on this diagram? Okay, yeah, that's correct, right? Yeah, that's correct, right there. Okay, good. So there's GP9. Now, when you want to actually use GP9, you actually look at its corresponding location. So this is on the left side of the breadboard, and it is 12. So I can now look on the left side here, find 12, and there it is right there. Okay, so that's how I identify pins. So always use that little reference unless you somehow manage to memorize it, which seems unlikely. Now, when I create a circuit that goes from one of these pins, and this value can be either high or low, or 3.3 volts or 0 volts, depending on whether the Pico, depending on how we program the Pico. I usually try to use a color other than red and black. So red usually means it's connected to a positive voltage. Black usually means it's connected to ground. So I'm going to go from 12 on the left-hand side as I indicated. And now I can go to any of these rows right here. Just going to randomly pick one there, 23. And the next thing is I'm going to use my resistor. It's orange, orange, brown. That means it's 330 ohms. You can also use a multimeter to figure out the resistance, or just the labeling of the package it came in. All right, so I'm going to go from, remember, in order to be connected, you must put one of its legs in the same row with, in this case, the blue jumper. So there that is. And then the other end, I'm going to actually put this, make sure that use the longer side of the LED. It has to be towards what's going to be the positive voltage. And so that goes here. And now I put the other leg in this pin. Sorry, this socket. And then finally I need to close my loop. And I will use black because it's going to go to ground. So it's going to go here, and it can be on any of these sockets in this row. And now, where is ground? Well, if I look at my diagram again, you'll notice that ground, abbreviated G and D, is actually available in multiple different slots. So I'm going to actually just pick this one here. This is the right-hand side, and it's going to go to ground. And that looks like 18, so I'm going to find that, and there it is. Okay, so I believe that I have my circuit, and now I can turn to my software. Okay, so now I have my Thonny open here, and one thing that's always important, I always encourage people to do, is to make sure that these files over here, this section is available and visible. If it is not, then what you need to do is go to your view menus and then select it. Okay, so you see if I deselect it, it disappears, and I select it and it comes back. And the reason that you want to do this is it will show you the files that are actually on the Pico itself. And furthermore, if your USB is not connected correctly, then this piece will not show up. So when you can see these files, you know that it's connected correctly. Now, one thing that's very important is if it is not actually connected, then you always need to go down here to the bottom right hand corner, and you'll see that there is a selection here. So if you go here and you don't see MicroPython, then there's something wrong with your connection, the USB between your computer and the Pico. Otherwise, just go ahead, and it may already be selected, but go ahead and select it again, and that should result in this appearing. Okay, now I'm going to go ahead and create my file. So I'm going to do new, and here it is. So when you write a MicroPython file program, there are three parts. The first is we need to import the packages that other people have written that we're just going to use. All right, so I'm going to go ahead and I'm going to do from machine import pin. So machine is the library, the main one that comes along with the MicroPython that allows you to program the Pico. And pin represents, well, it represents the pins on the Pico. All right, so that's the first thing, is you actually do all your imports. The second thing is to tell the Pico which pins we're going to use and how. So the way that we do it is we create a little variable. I'm just going to call mine LED because it's going to be connected to the LED. And we assign it. And the way that we do this is we create pin command. It's actually creating this object, a software object. We give the number, the pin number. So this is the GP number, not the number on the breadboard. And then we actually say, hey, this is actually going to be a signal that is going out from the microcontroller. All right, so now we've configured that, and now we can use different commands that are available on the pins. So I'm just going to do this LED.on, and if all is right, that should actually successfully turn on the LED. Okay, now I'm showing the board here, and so theoretically, when I run this, it should come on. But before I do this, I'm actually going to go ahead and save my program. Notice up here on the tab, it says untitled with an asterisk. That means it has not been saved yet. Now, if I go to my save, and I can do this through File or through this little Save button, then you notice I have a choice. I can save it onto my computer or on the Raspberry Pi Pico itself. I'm going to go ahead and save it on the Pico, and I'm going to give it a name. I recommend no spaces in your names. I'm just going to call this LED, and you always need to save your Python files with the suffix .py at the end. So I did this OK, and notice that it shows up here. Okay, now I'm going to go ahead and I'm going to run this program. So there is a button up here, this green button. Go ahead and run that, and if we are lucky, then hey, it actually worked. So this little program with our wiring has made it so that we've used the Pico to turn the light on. Now I know what you're thinking. Now how can we turn it off? Well, you can probably guess. So I'm going to go ahead and add that code in, and if you guessed that it would be LED.off, then you are absolutely correct. Now make sure that you have your open close parentheses. In programming, parentheses mean a lot. So I'm going to do this. I'm going to go ahead and save it. By the way, you might notice the star came back here, the asterisk. That means that I have not saved it yet. So you can save it with this button, or Command S or Control S, depending on the type of computer. Now I'm going to run this again, and let's see what happens. Well, I just see it go off. I'm going to run it again, and sure enough, I don't see it going on at all. And the reason for that is because between the on and off, this command happens so fast that we don't have time to see it. So what we want to do is between the on and the off, we're going to put in a little bit of a pause. All right, so we're going to put in a pause. And how do we do this? Well, there is a command called sleep. And in the parentheses, you put in the number of seconds that you want to sleep. If I run this, however, you'll notice another little problem. I'm going to go ahead and run it. It'll automatically save. This rather angry message shows up. Sleep isn't defined. So whenever you see something like that, a very good chance that you need to add an import at the beginning of your program. I'm going to go ahead and do that, and it's from time import sleep. And I'm going to go ahead and run this, and let's see what happens. Okay, it goes on and off. Okay, let's run it again because it had left over. It was on from the previous run. So I'm going to turn this so it's on, and then it turns off. All right, so we have successfully written our first MicroPython code.